Roofing day. Okay, here we are up on the roof, getting this little section that connects the roof to the new roof to the existing roof. Lots of geometry, lots of angles going on here. We're making a hip right here. So here we have our hip roof. Lots of compound angles going on. And so we've got to figure out the angles that connect the hip beam to the edge of the ridge on this addition, this new house. Lots of angles. So we got complex angles, we got angles going up the roof. Let's show you some angles here. So we have what we call a compound angle going on here. So we've got angle coming down the roof this way, and then we've got an angle of this board right here. So this is called a compound miter. So this guy, if you can see on that board, it's got an angle going side to side, and obviously it's got an angle going this way. Lots of angles. This guy up here is going to join. It's got an angle also, and then see the end of it. Hard to see, it's got a little notch out of that. It's going to have a little point because it's got to fit right in that. A whole lot of angles, and that was definitely a project that pushed my understanding of angles to the max there. So let's talk about angles here, all right? Angle is where we have two rays that share an endpoint. When we measure angles, we're measuring it in degrees. So when you think of an angle, think of the amount of rotation, all right? So when we measure it, if we go all the way around in a full circle, that's 360 degrees. If we just go halfway around like that, that's 180 degrees. So we use a protractor to measure angles here, all right? So protractor can break up an angle 360 degrees, or 180 degrees is half of a circle, so 180 would be this half angle here, all right? Half a circle, I should say. Okay, and so we've got these markings here, okay? And notice how this side's lined up with the 0. It's kind of hard to see under there, but there is a 0 there, all right? And so if we read the inside angles here, we can see that that's 140. So on the inside angles, this is 140 on this end, and it's 0 on this end. And there's a postulate called the Protractor Postulate that says if we subtract those, that's actually the measure of the angle. So this is a 140-degree angle. There's a difference of 140 degrees. Well, what if you use the other ones? You know, what if you read the outside? Oh, there's 40 and there's 180. Well, if you take 180 minus 40, that's still 140. So this is a 140-degree angle. There's 140 degrees difference there. Okay, so that's called the protractor postulate that says if we line up these two sides on the protractor and we put the vertex in the middle, that's important, the vertex is in the middle, then we can subtract their marks there, the two measurements, and get the total degrees for the angle. All right, so just a little try a few here just to get the hang of it. BOC, well, what's that? Well, this is at 35. See, there's 30, and so 35 is right in between. This guy's at 65 degrees. So BOC would be 65 minus 35. And that's going to be 30 degrees. See that? Maybe pause the video there. You can try these out. Or do them with me here, all right? So how about BOE? So BOE is the angle that goes from this B to O to E. So first thing that's important is we've got to be able to recognize the correct angle. BOE is that one there. What is that angle? Well, that goes from 35 using the inside angles there, and this is at 145. All right? So 145 minus 35 gives us 110 degrees. How about COE, this guy right here? C to O to E, that angle right there. Well, let's see, we've got 145 on one end and 65 on the other. And if we subtract those, we get 80 degrees. All right, I think you're getting the idea there. COD. This one, let's see, we need that inside. We're using the inside numbers here. You got to use either all inside or all outside. So we got 110 is what the D line is at, that ray. 110 minus 65. Yeah, maybe what, 35, 45 looks like, 45 degrees. BOD, how about that one? From B to O to D. Again, just find those angles. 110 minus 35. And that's going to be what, 65 and 10, 75 should be there. And AOE, this one, actually the last one is the easiest because we have this angle right here is at 0. All right, that ray I should say. So that's just 145 degrees. Maybe we should have started there, huh? Don't necessarily need to subtract because one of them is at 0. So, all right, so that's the idea. So we can measure angles, all right, so using degrees and using a protractor. Now let's look at some equations where we have a couple of angles being added together. So we looked at this thing called the segment addition postulate. Remember that? So we worked with that where we had a segment, and if we had two parts, A to B and then B, C, the length AB plus the length BC was equal to AC. That's the segment addition. The parts add up to the whole. Okay? Well, here is what we call the angle addition postulate. So if we have two angles, the two small angles add up to the whole angle, all right? So this small angle here, RSP actually, so that has a measure. Looks like maybe it's 30 degrees or something, okay? But we call that RSP is the angle, and the measure of that angle we write as the measure, we put this little M outside, angle RSP. And then we've got angle PST, that's this guy right there, all right? And so the measure of that angle would be the measure of PST, that's the symbol, okay? And then this whole angle, so those two little angles, you know, maybe this one's 30 degrees and this one's 35. Well, those are going to add up to the whole angle, and that whole angle looks like RST. Okay, so together, the two little ones add up to the measure of the big one. Okay, pretty straightforward. That's why we call it a postulate. Makes sense. So, we can use that, and we'll have some problems that we're going to work on where we have two parts. Here we got two parts. These two angles have to add up to the whole angle. Well, the two angles have expressions on them. The first one is 2x plus 10. That's this guy right there. And then the other angle is 4x minus 3 degrees. Okay. And so if we add those have to add up to the whole thing. And how big is the whole thing? Well, we're told here that the whole angle, LKN, is 145 degrees. All right. So now it's just algebra. So we combine like terms. Remember this? Okay, it's maybe been a while. We got to combine like terms, put the x's together, and then we can add the constants together. 10 minus 3, that's going to be plus 7. Then remember, when we're solving a linear equation here with just a plain old x to the first, we got to get that 7 out of there. So get all the constants on one side, and so we end up with 6x equals 138. And we can finish off, this is 6 times x. What's the opposite of multiplying?
divide. Okay, so it's probably been a little while since we've done some algebra. 6 goes into there. Well, it goes into 120 20 times, and there's 18 there. So that's going to be 20 and 3, 23. All right. So if you're wondering what I just did there, we could go to a calculator, but I think in my head this is 120 plus 18 divided by 6. You can divide that, and that gives you 23. Okay, 20 and 3. Anyways, all right. Well, what about this one? This one is a straight angle. Well, how many degrees is this straight line? Well, that's 180 degrees, right? So these two things together, the 10x minus 5, that's what we got over here, plus this angle here, the 4x plus 3, those two have to add up to the whole thing, which is a straight line. A straight line is 180 degrees. All right, then we can combine like terms. 14x, we've got, careful here, that's a negative 5 plus a 3. Negative 5 plus a 3 is going to be a negative 2 when you add them, right? Okay. Now let's get all these constants to one side. Let's add that 2 on over. 182 equals 14x. And if we divide by 14, okay, let's see, 182 divided by 14, I don't know, I'm thinking 182 is 140 plus 42. Okay, just dividing. This is a good way to divide. 140 divided by 14 is 10. So that's going to be 10. And then 42 divided by 14, I think that's 3. So 10 plus 3 is 13. Okay. How about if they make a right angle? A right angle. Now, we haven't talked a lot about different types of angles there, but hopefully we're familiar with that. Right angle means it's 90 degrees. So that little symbol there means 90 degrees, okay? So this is a 90 degree angle. And the two parts are 2x plus 2. And we're going to add on that other angle, x plus 1 there. Okay? So setting up the equation is probably the most challenging part. Well, sometimes solving the equation can be challenging. 2 plus 1 is 3. And we can subtract 3. We get 87 equals 3x. Then we can divide by 3. Well, I know that in 90 there's 33s. 3 times 30 is 90. So there's one less 3 here. That's going to be 29. 87 divided by 3 is 29. Okay, you go to your calculator, but well, it's good practice to practice dividing without your calculator. Okay. How about this? One more. Okay, so a new word here, bisect. Bisect means to cut in half. Like a bicycle has 2 wheels. To bisect sounds like dissect, but this means to cut in half. So if QS, ray QS cuts this in half, that's what we call a bisector, okay? QS is a bisector. It cuts it in half, okay? And we know that PQS is 1 as 24 degrees there. See that? So PQS is 24 degrees. And so PQR, well, that's the whole thing. PQR is this big one here. So the measure of PQR is going to be twice as big as that. Okay? So that's going to be 48 degrees. All right. Bisector means is something that cuts an angle or a segment in half. Okay? It's called an angle bisector. Okay, let's write that word down and be done. So this is an angle bisector. We'll see that more throughout the year. All right. Okay. Well, good work there. So now we can work with angles. We can find the measures, and we can use this angle addition property or postulate. Remember, the key here is that the parts add up to the whole, just like they did with the segment. The two small angles add up to the big angle. That's where our equation comes from. All right. Great job.